We average around 3.2 million gallons a day. Okay, it is designed for 4 million. And when it was built, they say back in 1970, it did cost around $4 million. Imagine today's standards would cost probably 5 times that amount today.
When I'm up early, I'll glance out a window and see if I can find a clear sky. Stars would indicate that it's going to be a clear day. That's when you have to start out, just before, when it's still pitch dark, and get down there before it gets light.
Today we have kind of a delicate subject, but one that's very important and even critical to the future of our river. We're going to be talking with Tom Hanneberg. He's the senior treatment plant operator at the Arlington Sewage Treatment Plant in Poughkeepsie. It serves the town of Arlington and IBM. We'll tour the plant and we'll learn the process that sewage goes through before it goes into the river. Also, we're going to meet retired IBMer Ernest Warnecke. He gets up early in the morning to capture the sun as it rises over the river. That's when we come back right here on the river. Before the passage of the Clean Water Act in 1972, raw sewage from homes and industries was dumped into the Hudson River, killing many of the plant and animal life. Since then, cities and towns have been rebuilding old treatment plants and constructing new ones to combat the problem. Tom Hanneberg is senior treatment plant operator for the Arlington Sewage Treatment Plant in Poughkeepsie.
The basic thing for a sewage treatment plant is to clean up all the dirty solids and waste from homes. We are a domestic sewage treatment plant. We don't have very little industrial waste, so it's just mostly all domestic waste. Most of the flow is all from the Arlington or town of Poughkeepsie area. We do have some flow in the 4th Ward, like I told you before. It goes down to the city of Poughkeepsie. We also have some 35, 36 pump stations that deliver the sewage down here. We average around 3.2 million gallons a day. Okay, it is designed for 4 million. And when it was built, they say back in 1970, it did cost around $4 million. Imagine today's standards would cost probably 5 times that amount today.
To judge the effectiveness of treatment plants, they are labeled either A, B, or C, A being the most effective. Tom says his plant is in the A category.
You get into A treatment, you go into activated sludge, or you get into tertiary treatment. Okay. B treatment would be probably primary treatment. That would be just primary thickener, and then like they would have sand beds or just something like that. Greenhouses, that's how it used to be, primary treatment here. They used to have just a greenhouse and used to let the sun bake the sludge, and then they used to lime it and shovel it out. So it used to be that probably B treatment. But this treatment here, which is under state mandated for 85% BOD and suspended solid removal, and we are well up in the 90% range, and we have been ever since I've been here. So this is a pretty good treatment plant.
Before we observe the different phases the sewage goes through before it's put back into the river, Tom will explain the stages in the control room.
We call, like say, preliminary treatment is where our influent flow meter is, pH meter, and that's called preliminary treatment for the reason that there's a bar screen that would pick up any rags that come into the system, any cans, so it can be mechanically taken off with a rake. And then we have an activated aerated contact chamber, and what it does is just when a solid comes through, it has grit on it. You would get that through your sewer line, and the air would knock the grit off the solid, and the grit would go into the bottom of a hopper. And we have a bucket elevator up there, and it takes out the grit. And the solids go on through, and we have a couple of comminutors which cut up all the material, if any rags or anything like that get through the solids, into about 1/4 of an inch in diameter. And that way you can be handling the primary tanks, and also for our pumps would handle it sludge with no problem at all. And like I said, the influent flow is right here, and right now we're up around 4 million gallons right now. But over the 24-hour period, it would be about 3-4, somewhere around there, because at nights it does drop off. pH meter, we are, like I said, domestic waste, and the pH meter should be normal about 7 on the pH. And so she's about 7.4, 7.5 right now. And that is all for preliminary treatment. And then we go into what we call primary treatment. That's where our next tanks, that's where the flow starts The flow comes into a tank and it, on an arc, is settled at the end of the tank. And there's what we call flights, and they bring the sludge into a hopper into the bottom of the primary tanks. And when we pump the sludge, we can figure out how many gallons of sludge we're pumping from right here. This is our primary. Right now we're running the primaries. About 80 gallons a minute we're pumping out of the primary tanks. And that sludge is settled, pumped into the thickener building, where it's settled into the thickeners. And when we get up to, say, 5 or 6 foot of sludge in our thickeners, we draw it off and we start burning our sludge. And we do burn our sludge around 1,300 degrees Fahrenheit. And all our ash and grit from the sludge goes to a menial landfill. We have a dumpster up there that you will see. Then we go from primary treatment, we go into our activated sludge, our biological treatment. And these gauges here are the amount of air that we're sending into the aeration tanks. You're keeping your bacteria alive. That's what the air does. It keeps them happy, because we are returning sludge from the secondaries. What it does, it just keeps the bacteria happy so they can feed on the raw sludge coming in, and you fatten them up so it'll settle out in the secondaries for you, so it don't leave and go out into the river. Okay? And so the air rate are these two DO sensors, and we're keeping the air rate around 2 to 2.5 parts per million. Okay? If you start to go too low on your air rate, you can develop maybe, say, filamentous bacteria, which is bad for sewage. You go into a septic type condition. Then you go from the aeration tanks, you go back down to your secondary treatment, which is these gauges right here. We're returning our sludge. Like I said, once we fatten them up, they settle back out in the secondary tanks. We bring them back to the head of the aeration tanks. It's more food supply. Back to the aeration tanks right here. And they're pumping back around about 360 gallons a minute to each tank. We can go to step aeration treatment. We can change these aeration tanks that let the flow run any way we want it. We go to help us if we get higher flows and stuff. Then we go to our final effluent, which the flow just leaves and goes out into the river, which is pretty clean.
Also in the control room, there's a map that shows the steps even more clearly.
We do take domestic waste from IBM right over here when you came in. And they have a couple commoners there, and there's a pump station that pumps IBM's flow into our main line. That's right here. So the main flow from Arlington and from IBM would go into the grit chamber area I told you, which is preliminary treatment. We have the grit conveyor and the elevator and the air compressor. The air compressor is just for blowing air into the... And it goes from there into the two commoners I told you, which cuts up the materials into 1/4 of an inch in diameter. That's so when it gets to your primary settling tanks, it will settle out and your pumps can handle the sludge that much better. And, these are your primary sludge pumps. Like I showed you, this one was running. All this pump number 3 is on. This light just tells you that pump is on. You go from your primary settling, then you go into aeration tanks. And that's where, as you can see out there, all that rolling out, the water out there, and this #1 aeration tank out here keeps it moving, keeps the sludge so the air can get to it and they can feed, and they're real happy out there. You go from your aeration tanks into your final settling tanks, which is right here. And like I said, we pump from the bottom of these tanks back into the aeration tanks. And when we have too many solids, if we want to waste it to keep our solids down, we can pump the sludge from the bottom of these right back to the thickener, where we waste. And we waste about 50 gallons a minute. Okay? That way, if you want to mix liquor, if you want to keep a mixed liquor suspended solids, so say about 1,000 parts per million in each tank, and you're up to 1,300 or 1,400, that's what excessive means. You can waste that many, 300, 400, to get it back down to 1,000. That way you keep everything at a maximum out there. It's after your final settling tanks, at your secondary, you do go into your chlorination tanks, and where the final is chlorinated. We use sodium hypochlorite. It's a 15% solution. That would kill any pathogenic type bacteria like that. And we do take coliforms once a week, and we send them to the health department.
In order to keep the river clean, Tom has 27 employees working around the clock 365 days a year, he says. If a problem should arise, a worker would be signaled by an alarm.
The main stations here, I think there's 10 stations on this board right here. This board is empty right now because it's in the process of being hooked up. These are the problem areas throughout the town where we may have had the biggest problems with homeowners, where a station went down and the flow backed up into their homes and stuff. So now, if we have a problem with the station, an alarm would go off through the telephone company, which is set up right down here, and it would light up this panel here for us, and we can just check the light. If it's Brooklyn Farms, we can call the gentleman up on the road, and they would go and check the station out before any problem would happen. And it has helped us quite a bit, because a few of those areas have been problems, especially Sutton Park Pump Station. We spent many nights out there taking care of problems out there. But that's the main reason for it. It's just to catch anything before it happens, any real problem, and to keep the town from being sued. That's the main reason. And this one here, like I says, the collection system does have over 35, 36 pump stations and airlift stations, and it is important.
Outside, we have a preliminary treatment facility whereby settleable solids are removed from the wastewater.
This is where the flow from IBM and Arlington comes together. And there is a coarse bar screen here, which any rags or cans or anything that does get in the sewer system is collected by mechanically taking off with a rake. The man comes up every hour and he just takes the rags off. That sort of flow would go through a little better and gets the rags out of there. And we go from there, we go what we call our aerated grit remover here. And when the solids come through with grit on them, the agitation knocks the grit off, which goes down to the bottom hopper, and the solids go on through into our primary treatment. And in the aerated grit chamber, there is, when the flow, it's beveled down like this, and there's an auger that brings the grit into another little drop-off, a little hole there, where there's buckets that ride inside the building there, that ride continuously and bring the grit and it empties out into the dumpster here. And when it's filled, we just put it into the dumpster over here, and we take it out to a menial landfill. Our grit and ash is disposed out there.
After preliminary treatment, the wastewater then flows into the primary treatment area.
On the preliminary treatment, I should have said the grit. Why we do remove the grit is, one reason is for our flights and for our pumping, because the grit is going to be very harmful to our pumps and to the packing inside the pump and stuff like that. It does protect everything for us. And when we get down to our primary treatment, what happens is that when the solids come in, this length of tank, they seem to go out like this, and on an arc, they settle at the end. And what we have in here that is running about 2 foot per minute are called flights. And what they do is they go to the bottom of the tank and they pull the sludge that settles up out there on the effluent end of the primary, bring them to a hopper, which is down underneath us right now, and the sludge is stored there, and then we can pump them into the thickeners with our primary pumps. Also, it's just like the grit chamber up there. There's a hopper and there's an auger, and it pulls the sludge into another little hole where there's piping is set up for our pumps, and we can pull the sludge off from the bottom of the tanks. You get most of our primary sludge is right from here, all of our primary sludge. These are two of the new tanks when they built the plant, and the two over there we call 3 and 4. That's from the old primary system. They were here way back in the 50s, so that's the old system. The building there and those old tanks are from the old primary system itself. All the rest is new.
Now for the third phase in the primary treatment process.
The sludge that settles out in the primary tanks is pumped with pumps that are downstairs. They're drawn off the primary tanks, and they're pumped into what we call a mixing tank. The primary pump is pumped up into there where we can meter it, so we know how many gallons that we're pumping up into there. Added to it is we call excess sludge. When we want to get our solids down our aeration tanks, we waste into the mixing tank. And we also have makeup water, which is like a clear liquid, which gives the primary and the excess a little DO. So when it gets into the primary tanks, it'll keep it fresh so it doesn't go septic on us. and the water, the excess water in the thickeners go back, what we call supernating, goes back to the head of the primary tanks and goes back into the primary tanks themselves. That's basically the whole operation. But we also have the unit over here is another grit unit. Like I showed you up in the preliminary treatment, we have another one here. When the primary is being pumped in, we can also pull out more grit. So then it starts protecting here. It doesn't help the pump that's already gotten through, but we do have another grit unit. These are called gravity thickeners, and they hold around 40,000 gallons each one, and the excess flow does go back to the head of the primary tanks. Because we pump our primaries about every half hour on the hour. We pump out of each tank every half hour.
After the primary treatment, the wastewater goes through the activated sludge treatment where a biological process takes place.
It's where the raw sewage comes in and meets our activated little bugs, the little critters in there we call them, and they like to eat the raw sludge as their food coming in. And what they do is we keep them happy, they fatten up, and they settle out in the secondary tanks. This empty tank, you can see from the rolling effect, you can see where it comes from them coarse air bubble diffusers down below down there. We used to have sock diffusers, and they used to clog up on us all the time, and we used to have to bring them up and clean them off all the time. But these here are pretty maintenance-free for us.
During the secondary treatment process, living microorganisms and organic matter are brought together in an environment favorable to aerobic decomposition.
This is one complete tank through here. You can see the flights on top of the influent section, but also on the effluent, the flights run underneath the weirs over here. In the hopper for collecting the sludge, these flights actually move around 1 foot per minute. And they collect the sludge, and the hoppers are right underneath here. And these gears happen to be the same as on the primary tanks, and they pull what we do, we have a couple of pumps downstairs here, and they pull the sludge out from the hoppers. And the sludge goes back to the aeration tank, and if we want to waste, or excess as we say, it goes up into the thickener building.
Now the wastewater is disinfected by means of a chlorine solution to kill harmful organisms which might carry disease. This is the last step of clarifying the wastewater before it goes into the river.
From the weirs there, you can see the flow goes over the weirs and then goes down into the chlorine tanks, where we have chlorinators which feed chlorine to each tank, which has a contact time of at least 15 to 20 minutes in with the sewage. That's the way we can kill any pathogenic germ that might happen to be there, which I doubt that is. We do have to send a color form once a week to the health department, and they let us know if we pass or fail. And 99% of the time we pass our color forms. The flow from the chlorine tanks go into a pipe which goes out and underneath the railroad tracks and out into the river out about 100 feet and about 25 to 30 feet down. And that's the final process for the flow.
The river plays an important role in the location of the treatment plant.
It's for the effluent, for letting the flow out into the river itself. That's the main. And one reason, I guess, is that the old primary treatment plant back in '59, they just add right onto it because they decided to keep the old building, the old digesters, and a couple old tanks from the old primary system.
As for the solids, they're burned in an incinerator and taken to a landfill.
All right, what's happening now is the sludge that's settled out in the thickeners is now being pumped through this pipe here. What happens is it comes over to what we call a conditioning tank. Over in this yellow line, we're adding polymer. What that does is it thickens up the sludge, actually takes the water out of the sludge. When it comes down into the vat here, the sludge, the thicker part, is pulled by a vacuum system, pulled onto the coils here. And the water is pulled off with a filtrate pump, and the water goes back to the head of the primary tanks. The sludge then goes up over the wheel and onto that wheel over there, the conveyor belt. Then it goes from there, which is an auger down below, and is slowly fed into the reactor. And there's where the burning process takes place. We burn our sludge around 1,300 degrees Fahrenheit. It goes from there as sludge is being burned, it's like a fly ash. And what happens over on the other side where it comes out, water is added to it. Where it thickens the ash up and it comes over into a classifier. And in the final process, the classifier takes it out into the dumpster, and when it's full, we put it into a bigger dumpster and it's hauled away to a mini landfill.
Tom says the Arlington sewage treatment plant is prepared to hold sewage even in the worst weather.
Here, when we get heavy rains or heavy storm, we do get a lot of infiltration, and the flow could go up to as high as 8 million gallons. But most of that, when you get rainwater, that's good for sewage because it dilutes it a little bit. And as long as we keep our basic flow going through our tanks, we don't have no major problem with it. But if we do have some bypasses that help us. You cannot, by the county or by the state and regulations, you cannot bypass the plant entirely or just send raw sewage right to the river. You cannot do that. We do have like an aeration bypass. You get a heavy flow, instead of washing out our tanks, we can send it into different tanks. It helps out a lot.
Even though there are more sewage treatment facilities aiding in the cleanup of the Hudson than there were 15 years ago, for instance, Tom says there's still a need for still more.
I would say the small towns should have it, yes. I think we have the capacity of maybe a couple more tanks or so in here. But mostly spare parts is our main concern. If we have the parts, then we can handle the flow. And we are going into different operations now, like I said, with the belt press. And we are now going into changing some of our tanks over into new technology to non-metallic sprockets and flights and stuff. We're going to be working on that this year. See how that works out. It gives you something to do, you know, it gives you more, it makes you feel good that you have something else to do instead of the same old thing every day. That's what's good about this type of operation, so you can work inside and outside. You're not just stuck in one little spot.
Thanks to the reconstruction of this sewage treatment plant and others, raw sewage, Tom says, is no longer dumped into the river here. And he says he thinks it's only a beginning to a cleaner and healthier body of water.
I went swimming in the river and used to be able to put your hand down a couple inches and you couldn't see your hand. Now I hear people say, I don't swim in the river anymore, but I hear people say that it is cleaned up pretty well. And I think we are the first activated sludge treatment plant on the Hudson River at that time. I think now you have Beacon and Kingston too, and maybe the city of Newburgh, but I think we were the first. And it is important to clean up the sewage, because I mean it is quite a recreational for people out there on the river.
Ernest Warnecke gets up before dawn to capture just the right color and brilliance as the sun rises over the Hudson. Ernest began his photography hobby in 1985 after retiring from IBM.
I try to think of something different to do with a camera. And after I saw a few sunrises, I got hooked.
And what exactly inspires Ernest?
The beauty of the scenes that you can get at sunrises.
In order to get the right light, Ernest says it's necessary to start out early.
Well, what I usually do when I'm up early, I'll glance out a window and see if I can find a clear sky. Stars would indicate that it's going to be a clear day. That's when you have to start out, just before, when it's still pitch dark, and get down there before it gets light. Because the sun comes up over the mountains over there, or hills, whichever they are. But there may be cloud cover lying right down on top of those hills too. So then you may have to wait till it gets up above it, and then if you're lucky enough, you'll get a break in the heavy cloud cover where the sun is beaming through the clouds, or rather in between the clouds, more or less. That's when you get the good pictures.
Ernest takes his pictures mainly from local places.
Anywhere from Ulster Landing Park, I believe that's the correct name, down past Port Ewan, on the road that skirts the river.
Ernest says he's taken many photos since starting his hobby 2 years ago. He says there are two things in particular for which he looks when taking a picture.
Color and reflections in the water. And you never find the same thing. It's always different. The area is the same, but what you see from the reflection of the sun, depending upon the cloud cover, it's always different.
Spring and fall are Ernest's favorite seasons to photograph, and he says he uses a single-lens camera.
Use a Nikon single-lens reflex camera with a 50mm standard lens. From my experience, this camera does a fine job for what I want to use it for.
Ernest tells us why his favorite picture is the one that has a pinkish color throughout.
Because of the brilliance of the color in the water. And it's a unique color. Usually it's hard to find that type of picture.
As for where Ernest was when taking this shot,
that was down past Port Ewan, at the river's edge.
the beauty the sun radiates when rising over the river is definitely captured in the photographs of Ernest Warnecke, and he says there's a reason why he's going to continue with his hobby.
A bit of a challenge, and it kind of grows on you. Once you take a few pictures, have them develop and see what you've achieved, you like to go back and see if you can get something different or better. And that's the way it's been.
So there it is, photography and sewage treatment. Just another aspect of what goes on every day, right here on the river. Thanks for coming aboard. We'll be back same time, same place next week.